day, students and viewers. Okay, so today we will be discussing about the concepts of work and energy, okay, under kinetics. Okay, so first, okay, so we will discuss the simple definitions of these works and this energy. Okay, so just a review. Okay, you might be heard this in your high school lessons. What is work? Okay, so usually we define work, okay, so as okay, let us say work in terms of U is equivalent to force times displacement. Okay, okay, so this okay, okay, so this equation works if your body or your particle is moving on a perfectly straight direction. Okay, so let us say your body moves from this position. So let us say this is your initial position up to this position. Okay, so let us say from this position to that position. Okay, so let us say your initial position is your S1, and your final position is your S2. Okay, so maybe you have a consistent in order that this basic equation for work will be used, it should be that your force will be consistent, into which, okay, so it should be that your initial force and your final force should be the same. Okay, so therefore your work, which is usually represented by U, okay, you can also use W, it depends upon you. Okay, so there are books which use U for work, and there are also books that use W for work as so therefore your force is equivalent to F times S2 minus S1. Okay, so this is for, okay, so if it follows a straight path. Okay, so this formula applies, okay, when your force is moving in a straight path. Okay, so this is okay, so or you can relate. Okay, work is equal to force times displacement. Okay, so we all know that displacement is your change in position. Okay, so this is applicable when you are traveling in a straight horizontal path. So what if, okay, let us say your work the movement of your body is erratic. So let us say you have a force. So you have an initial force here let's say this force, then eventually this force makes you change travel in a path in which will end up like this. Okay, so let us say this is your initial position, and this is your final position. Okay. So in case that the movement of the work of your force, okay, so when we say work, there is always equal to force. Without, okay, so without force, without mass times acceleration, there will be no work, okay? So in reality, so if a body is moving at a constant speed, perfectly constant speed, there is no acceleration, therefore, there is no work, okay? So that is the case. So, okay, so I use this is actually a dot multiplication, okay? So therefore, okay, so if that is the case in which there is, okay, so let us say, I'm sorry, so it should be like this, okay? So there is, it is not perfectly, it is not perfectly, it is not perfectly horizontal, in which it is at a position, it makes theta degree with your horizontal. So your force, okay, so this is for straight path, straight horizontal. So, okay, this is good for straight horizontal path. But if it makes theta degrees with the ground, so we use F cosine theta multiplied by your displacement or your change in position. Okay, so let us say this is your S1 and this is your S2. Okay, so it is not only simple as work is equal to force times displacement. Okay, so it is good only if it is moving in a perfectly horizontal path. But if it is inclined, you use F cosine theta to S1 times S2 minus S1. Okay, so if your force is moving in an erratic manner, okay, so this is erratic manner, let us say your particle is moving at a manner that is erratic, okay, so in which your initial direction of your forces is moving, and then the direction doesn't have a fixed um, direction or a constant direction of your force. So therefore you can use, okay, this formula, okay, so you can use you can graph this movement of your force in terms of, let us say, this is your, okay, so from a fixed axis, so let us say S, okay, so let us say that your erratic motion will be in S direction, okay, so it could be curvilinear. So S is your displacement, okay, so but this displacement is we measure relative to the path, okay, so it doesn't matter what position you are, okay, so if this you can make a graph in which your force to your displacement, in which it will be like this, okay, so let us say in between your initial, let us say, your initial position and then your final position. Let us say this is your, okay, so maybe let's put it here. So from, let us say, between 2 points in which, okay, we compute, okay, so we compute your work, the work of your force into separate instances. So let's say this is S1 and S2. Okay, not necessarily you start at the beginning. Okay, so if that is the case, your work from 1 to 2, okay, is equivalent to, okay, work from 1 to 2 is equivalent to F, okay, it's equivalent to the integral, okay, integral of F okay, so integral of F ds times S2, upper limit is S2 up to S1. Okay, so that is, okay, so how you okay, so in which your F is a function of, okay, is a function, could be a function of time here. So if you have a general formula for F, okay, you can replace that value here and then you can compute your work. Okay, so that is how you compute the work of your forces moving horizontal or in an erratic manner, or in a manner that okay, in which is following an equation of force relative to time. Okay, 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 so here, okay, so I would just like to clarify, in these two equations, the forces should be constant. In this situation, your force is not constant. It is always changing. So if that is the case, okay, so I'm sorry. So since your work is non-concern, okay, so that is the case. So maybe in order to lessen up the difficulties, just remember these formulas. So these two equations, okay, so this first equation is for the straight path, perfectly horizontal straight path, and this, if it is inclined, you use this formula. And if its force is constant, is changing relative to time, or maybe it could be also that your force could be also, okay, you can also use it can be also a function of your displacement. Let us say S. You can also use X if you want. Okay, it could be X, it could be. So you use this formula in which the work between 2 points, between 1 to 2, okay, is equivalent to this. Okay. Also this one, you can name this as work from point 1 to point 2. Also this one, work for you from point 1 to point 2. Okay. So that is your the formulas for work. But actually there is two more, okay, that we could discuss. So this is the work of your force, okay, but there are two others. So all of them are positive. Okay, it depends if your the secondary position or your final position is bigger than your initial position, so you will have a positive value. But somehow there is another one. So maybe I will use another board. Okay, so beside these three, okay, so your the value your work can be also caused by its position relative to the vertical. Okay, so it can be also work can be denoted as, okay, work of gravity. Okay, okay. So unlike those following three, okay, so we base it relative to, okay, horizontal. Okay, so there is also a chance, okay, okay, this is gravity. Okay, so let us say your particle is moving and from this position to that position, so there is actually a work that happens. Okay, so if its initial position is this and you have a final position in this axis, so there because of a change in elevation, okay, change in elevation or change of position relative to y-axis, there will be also what we call work of gravity. Okay, so your work of gravity could be computed as, okay, since the force that, okay, that caused by the mass is equivalent to W, which is mass times G, or mass times the acceleration due to gravity. So therefore, okay, so they're the same. Okay, so this is initial, let us say initial position, and this is your final position. So therefore, okay, the work of your gravity, let us say U, is equivalent to the weight. Okay, so since in a sense, okay, so it elevates its position while your acceleration to gravity is downward, so therefore it's negative. Okay, so the work of your gravity is negative. Okay, negative, okay, mass, negative W times, okay, so times the change in y. Okay, so that is the work of gravity. Okay, so we have, okay, the work of force, okay, horizontal force, and then we have the work of gravity. And then lastly, okay, so there is another special okay, a special work, okay, for a spring. Okay, so basically, we have these formulas, and this formula which is a work of gravity. So then we'll discuss another form of work. Okay, so maybe I will put it in this here. Okay, so I will put it here. I will just erase. So it is what we call, okay, so please memorize this